Hey Code Crew, what's going on? Today I'm going to go over some database options and what I like and what I don't like about each one. Specifically, we're going to go through MySQL, CloudKit, Firebase, Core Data, and Realm. Now that's a lot of options to go through, so I won't spend that much time on each one. I'm going to give you an overview, how data is stored, how much it costs, and pros and cons for each of the options. So, alright, let's get started. Undoubtedly, MySQL is the most popular out of all the options we've listed. Traditionally, MySQL has been used for web development and powers many websites, including my own. The most popular content management system, WordPress, which is installed on over 16 million websites, also runs off of MySQL. However, what's right for web development doesn't mean that it's automatically right for app development. Before you can understand the difference, let's talk about clients versus servers. Think of a server as a computer sitting somewhere whose sole job is to receive requests and send responses. In the web development scenario, we call this the web server. Your database sits on a database server. When you sign up for some website hosting and you create your website, those files also sit on a web server. Your browser, like Safari and Chrome, is called a client. When you launch the browser and you visit your website, your browser makes a request to the web server. The web server then requests the data from the database server, combines that data with HTML and CSS, and returns it as a response to your browser. Then your response renders that HTML and CSS code on the screen for you to see. So that's what happens in web development. In app development, your app is a client just like the web browser. It cannot connect directly to the database server. It needs some sort of middle layer, just like the website files in the web development scenario. For app development, we call these files web services. These web services sit on the web server and wait for requests. When your app makes a request to the web service makes a request to the database server and returns that data in some sort of format that your app will understand. Typically, it will be the JSON format that you learned about in the beginner course. So here lies the challenge with using MySQL as a database solution for mobile apps. You need to build the app client and the web services yourself. Whereas in web development, the browser is already built for you and you only need to construct your website. Now, I'm not saying that we should never use MySQL for app development. For example, you might already have a MySQL database full of data and you're looking to build an app to serve that data up. Another example is that you already have a membership site where all of the user accounts are stored in a MySQL database and you're looking to make a companion app for your website. Or maybe you are already familiar with using MySQL, SQL queries, and writing web services. Then go ahead and use it for your app too. However, if you're starting a brand new app that is free of any constraints, then consider all of your options first. Next up, we're going to talk about how data is stored in MySQL. Data is stored in a MySQL database much like how a spreadsheet would be organized. For instance, you might have a spreadsheet to keep track of all of the employees in your company. You name the spreadsheet employees, and inside it, you create columns to represent different details of each employee. Then, each row in the spreadsheet would represent one employee. In MySQL, you have tables instead of spreadsheets, so you'll have an employee table. A MySQL table is organized exactly like your spreadsheet. You'll have columns for the different pieces of data you want to track per employee, and each row in your table will represent an employee. Now let's talk about how much using MySQL will cost. In terms of costs, most web hosting plans come with a MySQL database, and they can start as low as $4 a month. You'll also need a domain name so that your app has a URL to hit for your web services. This costs around $10 to $20 a year. If you're thinking about going down this route, check out the links in the description below. However, if you haven't explored all of the options in this module yet, I would strongly urge you to watch all of them before making up your mind. Next, let's talk about some pros and cons. Some advantages of using MySQL for app development are familiarity. Lots of people are familiar with how a MySQL database is structured. It's also tried and tested. MySQL has been around for a while. Now, some disadvantages are you need to write your own web services. This may require you to learn a completely different programming language such as PHP. Also, with a low-cost web hosting plan, you probably won't be getting the infrastructure to support high-load scenarios, and you also probably won't have any data redundancy. So if your database server goes offline, then your app won't be able to access it. CloudKit is Apple's back-end as a service solution to store your app and user data in the cloud. Now, if this is your first time hearing the term back-end as a service, it's basically all of the back-end infrastructure to enable things like file storage and data storage, user management and notifications and more, all done for you and available through a single API. Now, it sounds great, right? It is, except that these back-end platforms aren't free. However, most of these platforms have a free tier that allow you to use all of the infrastructure and services for free until you reach the limits of the free tier. The great thing about using one of these backend platforms is that you get a lot of robust infrastructure for your data storage. For example, data redundancy. Your data is backed up and synced across multiple data centers, so if one goes down, the request is routed to one that is online. Another freebie is load balancing. So requests for data get distributed across multiple data centers to prevent creating a bottleneck at one specific server. This prevents the scenario where your app is waiting for a long time for data because of high volume. Those are just two examples of why I like using these back-end services such as CloudKit. Now, we're not going to dive too deep into how CloudKit works, but I wanted to give you an overview of how the data is stored. CloudKit uses the concept of containers, databases, and records. Your app has one container which contains 3 different databases: a public database where the data is accessible by anyone, a private database where the data is accessed by a specific user, a shared database where the data is accessible between a group of users. Within each database, you store the actual data in what's called a record. Each record contains key value pairs just like a dictionary in Swift. However, each record is of a certain type, and you define these record types in your CloudKit dashboard. For instance, you might have an employee record type containing these properties, and a manager record type containing other properties. Then in your database, you can create employee and manager records. Each of these records will contain the key value pairs that you defined in the record types. Furthermore, these records are organized into record zones. So on the CloudKit page on developer.apple.com, there is a pricing calculator that you can calculate how much it would cost depending on how many active users you have. And you can see that it scales up as you get more and more active users. And even at 10 million active users, your total cost is 0 as long as you stay within these limits here. Now, before we mentioned that your app has different databases. There's a public one, there's a private one, and there's a shared one. The private and shared one, where you store data that is specific to a user or shared between certain users, that storage is calculated against the user's iCloud account limits, and it's not counted toward your app limits. However, the public data that you store is counted towards these limits here. Now, the next question is, what is defined as an active user? Well, actually, if you scroll down on the page here in this fine print, it says that an active user is defined as having active container usage. That means they've been using the database capabilities of your app within the last 16 months. And then it also tells you some of the fees that are involved if you have any overage. I have to start off with the major drawback of CloudKit, and that is that there's no official SDK for Android. They obviously have an iOS SDK that you can just drop into your Xcode project to work with CloudKit, and they also have a JavaScript SDK that you can have a web app connect to your CloudKit database, but there's no official Android SDK, which means that if you have an Android app, you're going to have to build a set of web services using the JavaScript SDK, and then have your Android app send requests to that set of web services which you built. Another thing is you can store public data on the CloudKit databases. However, private data is stored on the user's iCloud account. That means if you're using CloudKit and you're going to be storing private data, your users must have an iCloud account. Now this shouldn't be a problem if you're building an app that runs on iOS, because as part of the setup process for the device, the users have to sign in with an Apple ID or sign up for a new one, and that is basically an iCloud account too. However, if you're building an Android version of the app, an Android user might not necessarily have an iCloud account or an Apple ID, and they'd have to go and sign up for one. If your app is going to be Apple only, such as Mac OS, iPad app, or an iPhone app, then CloudKit might be an easy solution for you. So some pros of CloudKit include it's easy to use if you're developing for Apple platforms only, and there's a generous free tier. Now some cons. Users must be signed into iCloud to store private data. And it's not easily a cross-platform solution, even though you can make it work. Alright, so that's CloudKit. Firebase is also a backend as a service, but unlike CloudKit, it is cross-platform in the sense that it fully supports Android, meaning that it has a SDK for it as well. So if you're going to build an Android version or a web version of the same app, then it's going to easily be able to use the same Firebase database as your iOS app does. In addition to that, the Firebase platform also includes a lot of additional backend features such as notifications, user management, file storage, analytics, crash reporting, and more. There's actually quite a bit more, as you can see from their homepage. However, let's focus on the database aspect of the platform right now. The only tough thing about using Firebase for data storage is that you have to wrap your head around the way that the data is stored. Firebase is a NoSQL database. If you're used to writing SQL queries with a traditional database like MySQL or Microsoft SQL Server, then it's going to take a bit of practice to get used to using a NoSQL database like Firebase.
In Firebase, data is stored as a JSON document. Think about how we structured the question data in the quiz module of the beginner course. You can literally import that JSON document to the Firebase database. Here's how it would look in your Firebase database. To access data, you would just need to know the path to the element that you need. To add data, you can add key value pairs to existing objects or create new nodes. There's no concept of tables, rows, or columns. That's why it takes a little time to wrap your head around if you're coming from the world of traditional databases.
In terms of pricing, Firebase has a free tier, but it's not based on active users like CloudKit is. You're going to have to see how this fits within your budget and within the plans for your app. To be honest with you, my own point of view is that it's more important for me to get my app up and running as quickly as possible rather than worrying about incurring some extra costs. If I'm hitting the limits of the free tier, then I think that's a great problem to have, and I fully expect to be generating some sort of revenue from my app anyways. The only thing I'd worry about in terms of hitting the limits of this Firebase free plan is the file storage limits. If you allow your users to upload large files, then you might hit that cap pretty quickly.
So some of the pros are, the Firebase platform has a lot of backend features. Firebase is owned by Google, who is arguably pretty good at handling data. I would trust their infrastructure. Now some of the cons. NoSQL might take some time to get used to. Query efficiency also really depends on how your data is structured, and coming up with the data schema is a big learning curve.
Now, compared to the other database solutions we've talked about so far, Core Data is very different. First of all, MySQL, CloudKit, and Firebase are all remote database solutions. That means that the data is stored on a remote server somewhere where all your users can access it. Core Data is different because it's local on the user's device. That means that it's not the solution for connected scenarios like generating user accounts or having user-generated content. Core Data is a solution where you need data persistence on your local device. For instance, your app works with a large offline dataset that is stored locally on the device. Now notice that I've been very careful not to call Core Data a database, and that's because it is not. Core Data is an object graph manager, and you can think of an object graph as simply a bunch of objects and the relationships between those objects. Let's take a closer look.
Remember back in the beginner course, in the quiz app, we downloaded a JSON file which we parsed to get an array of question objects. Although there aren't any relationships between the question objects, this is still an object graph. With core data, we could preserve all these objects in their current state on disk and then bring them back later. It's like putting this graph on deep freeze and then thawing it later to get back all of these objects. The cool thing is that you don't have to get back all of them. You can query and look for what you need and retrieve a subset of your objects that are stored in core data. Let's take a look at another example. Let's say that you have an employee class and a manager class. The manager class actually has a property called managed employees that stores an array of employee object references. We create a new manager object and 3 new employee objects. Then we assign these 3 employee objects to the managed employees property of the manager object. Now this manager object has a reference to these 3 employee objects. Now this is an object graph with relationships. We could use core data to save this manager object and then later to get it back. However, before you can get to this point, there are actually a series of steps that you must first do. In Xcode, there's a tool called the Xcode Data Model Editor, which you use to design your data schema. Well, you have to first create your data model consisting of the manager and employee and how they're related in this Xcode Data Model Editor. Then from this data model, you generate the manager and employee classes. So instead of declaring the classes yourself, you first model them in the Xcode Data Model Editor, and then you generate the classes from that. And as a side note, under the hood, core data uses an SQLite database. That's something that is hidden from you and not designed for you to peek into.
The core data framework is free to use, and you can simply add it to your Xcode project and start using it.
Some advantages of using core data are, it's a first-party library. It's created and endorsed by Apple. It's easier to use now compared with before. It used to be that it took a lot of code to do routine tasks with core data, but Apple has now cut down on the amount of code needed, so it's the perfect time to get into it. And some cons. It's not for connected scenarios, so it really depends on what you're doing with your app. And secondly, it might be overkill if what you need to do in your app is just store some settings or store some offline data that isn't a huge volume.
If you fire up your browser and visit their website at realm.io, you'll see that they actually have 2 products. One is called Realm Platform, and the other is Realm Database. The Realm Database is what we're after, and it's open source and free to use. The Realm Platform is their paid offering that provides data synchronization capabilities to your app if you need it. In this course, we're going to be using the free Realm Database. All right, let's dive in.
In the previous lesson about core data, I told you about how core data can persist your object graph on the local device. Well, Realm does the same thing. At the end of the day, they are both used to persist data on the local device so that it can be retrieved later. However, the way they persist data behind the scene is different, and also how you implement these 2 frameworks in your Xcode project is also different. In the previous lesson, you learned that core data uses SQLite behind the scenes, while Realm just stores the data for your app in a file locally on your device. This file can be opened to look at the data inside. In fact, they have a free tool called the Realm Studio that lets you open the data file and browse or edit the data. With core data, you learn that in order to persist objects, these objects must be from a class that was generated from the data model, which you designed in the Xcode Data Model Editor. With Realm, you don't do any of that. You can persist any class you want, simply make it a subclass of object, which is a Realm class that has all of the code to make the magic happen. Furthermore, you dictate which properties of the object should also be persisted by adding this in front of the object declaration. Realm Database is pretty simple to understand and to get up and running with.
The Realm Database is open source and free to use. Realm Studio is also free.
Some advantages of using Realm Database are, it's a lot easier to jump in and use compared to core data. You don't need to understand as much about the framework and how it works underneath the hood. You can just get up and start using it, and it's pretty easy to understand. Another advantage is that it's got the Realm Studio, so you can actually browse the data local to the device, and you can edit, you can delete, you can add data into it, where compared to core data, you don't have that sort of administrative backend to use. Now, some cons Again, it's not for connected scenarios, so again, it really depends what your app is trying to do. And for this second one, make of it what you will, but Core Data is a first-party Apple framework, whereas Realm is a third-party framework.
So there you have it, my thoughts on MySQL, CloudKit, Firebase, Core Data, and Realm. If you want my opinion on which one I would choose personally, then stay tuned for the next video because that's exactly what I'm going to tell you guys. Now I want to turn it over to you. Which one appeals to you the most? And is there another database option that you'd like me to cover? Let me know by leaving a comment below right now. And lastly, if you like this video, please give it a thumbs up and don't forget to subscribe for videos every week. Alright, so we're going to talk again soon. Bye.